So we have seen what is TensorFlow. TensorFlow is a library or data handling library which will help us to arrange the more than three-dimensional data in an efficient way. In deep learning, we require such complex libraries which can handle the information and help us to process out this information. On the other hand, interacting with such complex libraries becomes difficult, and that is why we require a top up of that library which can help us interact with this library as well as data efficiently, and that we can do with the help of Keras. So Keras is something which kind of building up a bridge between the TensorFlow and the raw data. So as I told you, Keras is also an open source library, and it is capable of running on top of both Theano as well as TensorFlow, and it is considered as a heavyweight wrapper for both Theano as well as TensorFlow, and it is easy to use as compared to Theano and TensorFlow directly. When we talk about interacting with these environments or libraries, it is easy to actually work on it. But when we talk about Keras, it is easy. um, Keras actually uses TensorFlow in the backend, and Keras has multiple functionality like building up libraries and all. And Keras is actually integrated with TensorFlow after Google kind of acquired it. Keras runs seamlessly on CPU and GPU. It doesn't require a very higher order of graphical processing or any kind of thing. It helps us to work on both of the environment. It is compatible with all like Python 2.73, all the above versions of Python. By default, Keras will use TensorFlow as its tensor manipulation library, which means the data manipulation libraries. And the advantages are kind of there are a lot of advantages in Keras. When we talk about that, is it is user friendly. Interacting directly with the tensor is very difficult at times, and that's where Keras will come into picture, because see, the data that is coming to us is not always going to be a structured two-dimensional or something data which is kind of very organized. It can be a multi-dimensional data in a form of kind of audio, video, and all different segments of information. uh, that's why it requires like directly interacting with TensorFlow, which is already complex. It becomes difficult. So that's why Keras can definitely help you out to interact with such a data very efficiently and easily. Keras is modular in nature, like it renders standalone models that can be combined to create new models. So it is modular in nature. It is extensible, can extend the model very easily. It is minimalistic, like models are described in Python code, which is compact, easy to debug, and very simple to use. Like it is minimalistic, it doesn't require too much of exaggeration of codes onto it. Now we'll try to understand Keras. The way we have installed TensorFlow, similar way we can install Keras as well, either on your terminal or either it can be your command prompt on Windows. So you can open your terminal and you can simply type out pip install Keras, and it will install the Keras into your environment. Now, why we are using Keras, as we discussed earlier? So, deep learning research and development is carried out with powerful platforms like TensorFlow and Theano. These are tensor manipulation libraries, and that's why it is very important to use it for handling the data. TensorFlow and Theano can be difficult to fit in most of the time. Like most of the people are not that much skilled to handle such data, and that's where it requires a kind of easy build between the programmer as well as the machine. So TensorFlow, interacting with TensorFlow becomes difficult at times, and calculation and computation at the next level is very difficult. So we require an intermediary library like Keras that supports multiple backend engines like TensorFlow, Theano, CNTK. All these libraries, all these backend engines can be easily supported. Like Keras can help you support with all this tensor manipulation and data manipulation libraries. TensorFlow can be trained on a number of different hardware platforms beyond CPUs. Like it is not just CPU on which it is trained. It can be used on other hardware libraries as well. It allows us to perform fast experimentation, like it allows us to perform faster execution of code, and it creates a clean and convenient way to build deep learning neural networks. Like the interface that it provides is much more cleaner, and that is why if someone who is new to the programming environment or the deep learning environment also doesn't feel difficult to work on it. Pre-processing methods. So pre-processing method is a method of standardization to make the data easy in order to perform modeling on the data. Based on the data, we can choose the following pre-processing method. Like first is sequence pre-processing, second is image pre-processing, and third is text pre-processing. Sequence data usually in the form of RNN, which is sequential like time series data, or maybe it is a form of paragraph or something like that. RNN is the best way which can help us to uh, rearrange the data in a sequential format. Image processing can be done with the help of convolutional neural network, which will help you to work on the data in a very detailed way in a sequential manner or an image data. For text data, we can use the text data like Keras for performing text analytics on TensorFlow and do natural language processing. These are three types of pre-processing which are complex in nature, can be used using TensorFlow and Keras. So it actually enables us to work on these data handling libraries. Now we'll try to understand different pre-processing, as we mentioned, like sequence pre-processing, like time series generator. Here we take in a sequence of data points gathered at equal intervals of time to generate batches of data. Then we can use paired sequences to say to the same length as that of data. Like paired sequences help us to arrange the same sequences as that is there for the data. Skipgrams allows us to transform a sequence of word indexes, a list of integers, into tuple of words. Like we can use skipgrams. Then we have images. In images, we can use image data generator for augmentation of data and build up different tensor values of data based on augmented values of data. It is real-time data augmentation with different ways of arranging the data in vertical, horizontal, shared version of data. Then we have text in which tokenizer, we can use tokenization, converting the text to a token, and it can be saved as an array or tensor of data. Hashing trick, it converts a text to sequence of indexes in a fixed size hashing process. So text analytics also requires tensors or TensorFlow as a kind of base data handling mechanism. Now, layers in Keras. So, Keras is about like it is used for deep learning. So that is why in deep learning we require different layers of data, and that is where Keras will come into picture. Keras is about deep learning. It is used in Keras is about deep learning. It is used in handling the data, and in deep learning we require sequential architecture where sequentially we are going to place one layer after the other. An ANN becomes a deep neural network when no number of hidden layers are more. Like if you have more than one or two hidden layers, we call it as a deep neural networks. And in order to create this more number of neural networks, we require Keras. Keras has built-in layers that represent common qualities that can be used directly for a deep learning neural network. Layers are chosen based on the data requirements, and Keras helps us to build such layers. And you can you choose your own custom layers based with the help of Keras, and it has all possible sort of data layers that can be used for building deep learning applications. Few of the layers that we can see here is core layers. So basic layer of a neural network, usually the first layer in a deep learning neural network is the core layer or the input layer. Then we can talk about convolutional neural network. So convolutional layers creates a convolutional kernel that is convolving around an image or layer of information or tensor. It can be of the size that we will define, the kernel size we can define as per our choices in the convolutional neural network, and it performs convolving operation over that tensor of data. Pooling layers, it's downsamples the data using pooling technique, which means if we have a dimension n into n dimensional data, we can downsample it to n minus x into n minus x sample of data. So it kind of extracts the meaningful information from the data. Then we have locally connected layers, like convolution layers with unshared weights can be considered as the locally connected layers are also there. Merged layers is a combination of any of the layers in the data. Advanced activation layers, it is used for activation, layers for activation function. We have normalization layer to normalize the data passing through this layer. So if we can directly do the batch normalization or data normalization over here. Layer wrappers, so wrapper take another layer and augment it in various ways. It is only an abstract base class which is used. Custom layers, like user defined custom layers, can be used to provide user defined data. Now we will talk about models in Keras. So different models are there in Keras. There are two ways of composing models in Keras. First is a sequential method by sequential method, and second one is by functional method. In sequential method, you will create a sequential layer first and linearly stack one by one layers on top of it. On functional method, you will create a functional complex network of layers, and directly we will do it with the help of a function. Now we will talk about the sequential model. The core data structure in Keras is deep neural network model, which is the simplest way to stack up the layers one over the other. The simplest way is to stack up the layers, such as a model. Such a model is a sequential model of Keras, and it is simple, easy, and used for linear computation of information, and it does not allow shared layer or multi-input or output. Sequential model is most commonly used model which is there in deep learning because it enables us to stack up multiple neural layers one over the other. Sequential model, first of all, we have to initialize the model. Steps for sequential model. So the first step involves initializing the model, and then step 2 is about adding the layer to the stack. Then in the step 3, we compile that layer and configure the optimizer in step 4, where we will decide which optimizer we are going to use. Then after building that configuration, we will train the model, and once the training is done, we will predict the new data, and at the last step we will evaluate the performance of the model. So this is how a sequential model is built up using Keras. So the code to create a sequential model is starting with creating and importing sequential model. Model is equal to sequential, which is imported from keras.models. Then we will, from keras.layer, we can import multiple layers like dense layer, dropout layer, and all. We can add all these layers, and we can specify number of units, like number of neurons, what is the activation function, what is the input dimension for the input layer. We can add multiple dense layer also, which are acting as a hidden layer. And finally we will add the softmax function. Softmax function will help you to do a multi-class classification over the data. Step 3 is about compiling the data, where we validate that our model is ready, and now we are compiling the data with the help of a certain optimizer. We can specify optimizer like Adam, SGD, mini batch gradient descent, ADA boost, and something like that. And we can keep at accuracy as metrics, so that when we are keeping accuracy as the metrics, so it will keep on improvising the accuracy in the model when it is trying to retrain or do the back propagation. And finally, after compiling, we can simply just specify and configure the optimizer. Like we can specify a particular optimizer also. Like here in SGD, we can configure the learning rate, momentum, and Nesterov function to be true. In the step 5, once the model is ready, we can fit the training data, and we can also specify the epochs. Now, what are epochs? Epochs are number of iteration that we want the model to take on our deep learning data. So there is a data, and what we are going to do is we are going to pass in certain set of sample of data into that model, and model will learn from it. So we will first set up our training data. Model will grab some information, or deep learning model will grab a certain set of information, learn on it, and after learning it will decide, okay, what kind of error it is making, what is the challenges, and in the next epoch it will improvise. So it keeps on doing this epoch by epoch, and in every epoch it tries to improve from the previous epoch. Then we use the class is equal to model dot predict. Predict function will help you to predict something new um, from the data, like it will help you to predict. You have to just pass in the data. And performance evaluation can be done with the help of model dot evaluate. It will tell you like what exactly is this model about, how much weight the model has, and everything. So we can use the performance evaluation of the model, so it will tell you weight, size, and everything about the model, how much weightage it is carrying. Now we'll talk about models with functional API. So the Keras functional API allows defining complex models such as multi-output models, directed acyclic graphs, and models with shared layers. So um, the Keras functional API is basically easy to use and helps us to train the model as layers. It is easy to share the layers between models. A layer instance is callable and it returns a tensor. Input tensor and output tensor are used to define the model, and unlike the sequential model, you must create and define a standalone input layer that specifies the shape of the input data. So we can develop a model with the help of functional API as well. Like it is basically easy to reuse the trained model with the help of layer, and there are a lot of benefits for this input model with the functional API. So it helps us to input tensor and output tensor can be utilized to define a model. Now, model with functional API, how we are going to create. So first we have to create or grab in the input uh, function from the layers part, and we define the input shape is equal to minus 2 comma something, like whatever is the shape of the data, input shape of the data. Then we create the layers. So from keras.layer we call in the layer, and we are calling the dense layer, for example, and in dense 2 we are going to put it as visible. Step 3, we are going to build the model. So in the model we are going to put input is equal to visible. Visible is nothing but the input layer, and output is equal to hidden, that is the number of neurons or number of layers that we are talking about. Then we will compile the model. So for compiling the model we are going to use the model.compile in the same way that we have done, and we are going to specify the loss as the metrics. Like we don't want the loss to get increased, we want the loss to reduce, so we are specifying the loss. In case of a binary modifier or binary classification, we use binary cross entropy. Loss weight is 1 comma 0.2, which helps us to monitor the weight. And model dot fit will help us to fit the training data. So we will first fit the headline data, training and validation data, and the training and validation labels or a wide data. And epochs is equal to 50 and batch size is equal to 32, that we have to specify, which means this model will train on 50 samples of data and every sample will have a size of 32.